Hello, I'm Megan Morys-Carter, Director of The Hill. Welcome to Series 3 of our Digital Innovation podcast. The Hill supports an ecosystem of startups, scale-ups, partners and clinical staff interested in digital innovation, as well as managing a pipeline of innovation into Oxford University hospitals and the wider NHS. Our work supports better patient care through technology and innovation. This series explores some of the technologies that are at the cutting edge of healthcare delivery through the medium of the entrepreneurial journeys of some of the founders in our community, as well as the clinicians they have worked with to pilot their technologies. So Andreas, welcome and great to have you on the podcast. Can you start by giving us a brief summary of OXcan?
Yeah, thank you very much. I'm looking forward to speaking. So Oxford's Cancer Analytics, we started 5 years ago, and our mission is to transform cancer management through early cancer detection. We want to make it possible through a simple blood test to be able to screen patients at risk of cancer, detect the cancer early when you can have a treatment intervention for the cancer, and by so doing, hopefully impact millions of patients around the world and thereby ultimately billions of people and their families.
That's fantastic. I mean, I'm always very excited to hear about what OXcan is doing next because it seems like you've got a really innovative technology that could really change people's lives. And obviously that's, I guess, the exciting thing about being an entrepreneur is being able to have that impact.
Definitely. Yeah, I think it's really interesting is always asking yourself, what is the problem area? What are we trying to do and why? And how does everything fit in? And, cancer is one of these things where so many people have been affected by it, either directly or indirectly. And it really comes down to the fact that through a variety of factors, it's a combination of genetic factors and environmental factors, lifestyle factors, we can see that cancer is on the rise. Some statistics suggest that ultimately it will be, 1-2 people who will be diagnosed in cancer in their lifetimes in the UK and many other areas as well. And the problem is that in many cases, the deadliest cancers are diagnosed at a late stage, which basically means that the cancer is starting to spread to other parts of the body. Lung cancer is an example of that. It's the biggest cancer killer worldwide. And that's what we're focusing on initially, because if you detect the cancer at such a late stage, then the options for treatments are very narrow and also patient survival is very low. So we want to make it possible to detect the cancer early when treatment can still be used, hopefully to remove the cancer. And by so doing, you need to have a way which is inexpensive, very scalable for patients on a wide level. And that would be in public healthcare as well as also private healthcare. And it has to be accessible to people who really need it. And of course, the technology has to work because so far, historically speaking, there hasn't really been a solution to this problem.
So can you tell us a bit about how it does work?
Yeah. So ultimately, what we're trying to do is ask ourselves from a really basic biological question here, which is, when a cancer develops, initially it starts off in a certain area, a local space, a tumor, it grows. And, there are a variety of ways of describing the process. We've got, of course, got the famous Hannah and Weinberg's hallmarks of cancer and how there are different aspects of the biology which need to change for cancer to mature. When the cancers develop, as is also the case with other tissues in the body which are healthy, you always have some materials from the tissue which is released. And some of that material ends up in fluids in the body, such as in the blood. So, for example, you may have nucleic acid material, DNA and RNA, and some of those fragments might end up in the blood. And you could then, if you have enough sensitivity, detect those materials. Protein, really, of course. So there's this whole concept of the central dogma, which is that you've got DNA and you've got messenger RNA, and then you've got translation to protein. And ultimately, whilst DNA can be seen as a blueprint, protein is a functional snapshot of what's happening in the body right now. And so if you have certain mutations in DNA, you'll have mutated versions of certain proteins. Or it might be that you have higher or lower levels than normal of a protein being made as a result of some genetic change, for instance. And so what we're trying to do is really ask ourselves a question: can we detect different materials released by a tumor which are detectable in easy to collect fluid? Blood being a really good example of that, because patients can go to a family doctor, GP, have a blood sample taken, which is standard to do anyway in clinical care. And if we can then tap into that and to detect materials predictive of cancer, that's great. And then in addition to materials which are released by a tumor into the bloodstream, you also have general changes in metabolism, which will be correlated with increased risk of cancer, or also comorbidities, which are also important to take into account. So if you can get that pattern and you can say, these are the particular potential biomarkers, and we're focusing mostly on proteomics, but we're also looking at other approaches at the same time. And if you've got that signature associated with early stage cancer and beyond, then by screening patients, looking at those signals in the blood routinely at risk, hopefully we can get those patients at a time when the cancer is early and we don't need to wait for symptoms to appear. Whereas normally in clinical care right now, by the time patients have symptoms, so for example, with lung cancer, it could be a cough, it could be back or shoulder pain. But of course, that doesn't have to be cancer. It can be other things. And sometimes it's difficult for patients to really go in to see their GP. So by the time that symptoms appear, often the cancer is at late stage. And we don't want to wait for that. We want to know in advance through a biologically oriented approach, combined with risk factors and patient histories, how we can really personalize that detection.
And are you finding that there is always the same signature for a particular type of cancer, or are you finding that there's sort of several signatures which might lead you to the same conclusion?
Yeah, that's a fascinating question. So there's the core biomarkers which are associated, generally speaking, with cancers. But then if you look at lung cancer, which is where we're focusing, of course, there is lots of heterogeneity. What does that mean? Well, you can have different people, of course, with different subtypes of cancer, but it's not just that. We've got so many different aspects of heterogeneity. You've got environmental differences. So, for example, smoking history. But what does that really mean? I mean, you have people who might have smoked quite heavily in a short space of time, or for a longer time, but slightly less. You've got people who are exposed to environmental pollutions. For example, it could be through traffic. If they're living in an area where there's a lot of traffic, that might be applicable, especially in certain city areas, not just in the UK, but other parts of the world. So you can see also, if you're looking at Asia, for instance, China and India, there's a huge increasing incidence of those forms of exposures as well. And then you've got, of course, genetic variations. So cancer normally clinically is divided into categories based on what the cells look like and where they're based. And also, of course, how the cancer is then developing. So, for example, if you look under a microscope, what types of cells are they and what is it that they look like? So we've got the concept of non-small cell versus small cell lung cancer, but then you've got different genetic subgroups that you have there too. And so you would expect that you have a heterogeneous signal. But what's really interesting is that even in the same person, over time, a signal can change. And that's because you have a developmental process and for the particular tumor developing, but then you also have many other factors, biochemically, physiologically, which may or may not be related to the cancer, which also change over time. So that means that if you're trying to detect cancer or any other disease type with high sensitivity and specificity, you need to have a test which is going to work for patients in general and be able to detect that disease, not be confused by others. And at the same time, it has to be sufficiently broaden the biomarkers so that you can cover those heterogeneous subgroups. So what we're really noticing in our own work is that there are biomarkers which, say, for stages of lung cancer, early and late, are in common. But then there are some biomarkers which are associated with early stage or late stage. Some biomarkers are in common between lung cancer and other types of cancer. Other biomarkers are specific to, for example, lung cancer. And that's really important too. And also to put this into context, which is there are so many different factors which can affect, in theory, how somebody's biology appears when you make one measurement. So we're trying to look at measurements from patients where you take into account through our clinical studies that there are other comorbidities, in other words, other diseases which someone may or may not have, and other lifestyle risk factors to make sure that we don't confuse the signal associated with cancer with the signal associated with other factors in the background.
That sounds incredibly complex. So, I mean, this feels like it's as much a sort of data and computational challenge as it is a proteomics challenge. Is that a fair assessment?
I think it's really, yes. It's all levels at the same time. So we have a laboratory space, and in our laboratory space, we do all of the wet lab work ourselves. And that's really one big part of it as well. So there's a lot of know-how in terms of how do you make the most unbiased measurements? If you look, we say proteomics, but that's such a broad term. So what actually are we looking at? So we're trying to really get an unbiased look at the proteome by not making assumptions a priori as to which protein to look for. We want to have a wide look at the proteins present in the plasma samples from a patient, which you can look at from the blood. And in addition to that, we also want to make sure that we incorporate any domain expertise we have in terms of which proteins would be involved in cancer. So there's a lot of wet lab work in terms of optimizing instruments, how you use the instrument, in terms of how you also then do the bioinformatics analysis when you get the raw data. And then, as you say, there is also this computational question of, well, if I've got hundreds to thousands, we've looked at over 5,000 700 proteins per patient sample. But if you look at thousands of different proteins, how do I make sense of that? It's like looking for a needle in a haystack in a sense. So in this, what's called in statistics high dimensional space, you need to then identify what is a succinct combination of biomarker candidates, which actually corresponds to the signal. And that is a huge computational challenge. And we've developed tools from a statistical and a machine learning perspective to deal with that. Some examples would be you need to be able to understand interaction effects potentially between different biomarkers. You need to, of course, be able to distinguish between noise in the background and signal. Noise doesn't mean insignificant. It just means it's not associated with what we're trying to identify here. And so it can be a distraction. So you need to be able to identify the key panel of biomarker candidates. And then you also need to make sure, again, that they include sufficient proteins for heterogeneous effects, but at the same time that you are specific to the cancer of origin. And then you need to understand how with different combinations, you may have differences in performance. And ultimately, we want to have a way of a panel which is going to be very sensitive, very specific, and scalable for patients as a whole. So far, we've been able to achieve 80%, 90% plus sensitivity and specificity compared to unfortunately what is a very low performance, 20% to 50% by lots of others who are trying to do work in this field, other companies. And we think it really comes down to this integration between the computational analytics with the unique way in which we're doing work in our own labs. And of course, it's the samples we have as well, because without having the right clinical studies, and thanks to patients and clinicians and nurses who are really helping in this space, without us having those unique collaborations as a company with academic institutions, it wouldn't be possible to have the right data. And unfortunately, a lot of cases in the past, there hasn't been the right use of data, or people just haven't had the right clinical study setups. And so from the very get-go, it's very limited. So it comes down to, the complexity comes down to the right patients in the clinical studies, the right measurements that you're making, in our case, focusing on proteomics, but also beyond that, having the right lab infrastructure and the know-how associated with that, and then also the analytics to make sure that we can turn that into what will then be the product.
It's a complicated environment being an entrepreneur, isn't it? I think it's really interesting to see how multidisciplinary the field is and how many different components you need to bring together, how many different partnerships, how many different types of technology in order to really have that unique value proposition. And it's one of the things I think that's really exciting about OXcan and what you're doing there. How did you get into it yourself? Can you tell us a bit about your story and how did you end up?
Thank you for asking. So this is really interesting. And I have to say it's inseparable from that of my co-founder as well. So 5 years ago is when Oxford Cancer Analytics started. I'll go a bit of background. So I'm the co-founder of the company and president of the company. My co-founder and the chief executive officer is Dr. Peter Liu. And we both met each other, a very long time ago in the United Kingdom. So the backgrounds are really interesting. So I didn't really expect to be an entrepreneur if you'd asked me 10, 15 years ago. What I did know is that I wanted to combine medicine with mathematics. So I was doing medicine at University of Oxford at St. John's College. After the first 3 years, I then went into a PhD, a DPhil, PhD in machine learning and medicine. And that was for predictive analytics in a variety of contexts, mostly respiratory disease. But that was, the entrepreneurship aspect, not for cancer analytics, was completely separate from what I was doing and from what my co-founder and CEO, Peter, was doing. His background was very much medical and oncology focused, a wealth of experience internationally in that context, also working at the WHO in his case. And then in my case, it was really that intersection between the mathematical medicine. And I was very open to how to apply that, as in which disease types to look into. But of course, cancer is such a big problem, which touches so many people and their families worldwide, and it's an increasing problem, unfortunately. And when myself and Peter met in Oxford, it was so apparent that we had lots of intellectual synergy and also the real passion to make a difference in this space, because we came across studies and we came across publications and other companies and academic groups who were trying to work in the space of early cancer detection. And we just realized that there was a huge gap. You often didn't have the right patient data. You didn't have a sensitive and specific tests for the deadliest cancers. And we knew that there was a lot that we could do through our own expertise and also others in our network. And so we decided to go on this path. We initially were part of the Oxford Foundry program and the Elevate Accelerator program. So there was the Oxford Foundry Best Ideas competition, which we won in February 2019. And that was really interesting for us because we didn't, at that point in time, have lots of experience in the world of entrepreneurship formally. But I think it's because we had the intellectual tools and very strong, networks in terms of the clinical space. And then with the training that we then got there, automatically, we were able to very quickly translate it into here. I think something beautiful about entrepreneurship is that you really can translate what is in theory, either in the lab or in silico in the computer, into practice. And it's that push, the ability to say, not just we're going to look at something because it's interesting, but we want to make a tangible difference in the world that we live in, working with different people, different stakeholders, everyone, patients, others who are, whether it be charities or investors or others who are passionate in contributing some form of way to this. That's really what the difference was. And the key, there's so many similarities between entrepreneurship and science and academia on one hand, but there were also some differences, which is, I think the pace is really fast in entrepreneurship. You constantly have to ask yourself the question, what is it that's needed? What are the implications of doing X, Y, Z now? How is that going to really fit? The good thing is that what we're doing aligns with the mission, which is to have a positive impact on patients. And both myself and Peter have that background where we want to see that impact for patients. And so what we're doing aligns with our moral foundation, what we're trying to do, which is to do good things in the world tangibly. And then, of course, I have to say it's a whole team effort. So we have a team, a very diverse team in terms of the different disciplines people come from and very international in the world. And I have to really say it's been thank you to everyone in the entire Oxford Cancer Analytics team from the very beginning until today, because without the team, we couldn't be where we are now. I'll just highlight a few. For example, Dr. Daniel Schultz, our Chief Product Officer, who has done a fantastic job in terms of so many things. His background is very interdisciplinary in terms of, engineering, biology, chemistry, many different aspects together. And he's been leading a variety of collaborations which are enabling us to get to where we are now. And there are others in the team from all over the world. So I think one of the beautiful experiences for me on this entrepreneurial journey has been to get to know other people who are passionate about what they do and who have the tools together as a group to actually implement it.
You've obviously got quite a multidisciplinary team and, quite a diverse team. And I think that diversity of thought is really helpful in kind of creating a strong product. Have you experienced any challenges with bringing those diverse opinions together? And how have you sort of managed that team and built that team?
So this is interesting because it's been quite easy in some ways and difficult in other ways. I would say what makes it easy is the fact that you've got people who are all passionate about what we're trying to do. So it's not just work for the sake of work. It's not just wonderful scientific research, which is interesting to those who are scientifically curious. It is something which can make a difference to people day to day in their lives. And so because we have a team of individuals who really care about that goal, we're already aligned in that way. So whenever there is a difference in perhaps the opinion on what we do strategically speaking, or which tasks and research we do first and what order, we already have the same goal at the end, which means that we're united in that. And then it's about listening to others. It's about trying to make decisions which are objectively the best, taking into account those perspectives. I would say one of the key things in management in the entrepreneurial context, but that also applies to many other things in life, is always to remember that one does need to prioritize. You can't do everything at once. There has to be one path that you go on. But at the same time, the idea is to take the best of everyone's contributions and unite it into a mosaic, which altogether is going to lead to something better than the individual suggestions would by themselves. And recognizing people's unique strengths on both an intellectual and an interpersonal level to be part of that journey.
I think having that shared vision is really important, isn't it, as an entrepreneur? And it clearly kind of brings you to life, and Andreas, to sort of talk about those. I mean, do you enjoy being an entrepreneur? I
do. And I would say that for me, it's not being an entrepreneur or being a scientist or being, being somebody who works in the field of medicine or research. It's not any of those things intrinsically for the sake of it that I enjoy. It's what I'm doing with it. If I know that the things I'm doing are going to have a good impact on individuals and society as a whole, in both of those cases, if I know that I'm using the skill set that I have to do that, then I think it's a beautiful thing. And that's why I think I'm in the stage where I am now. And I would say it's similar also for Peter, because in his case, also, if we had asked 15 years ago what we would have done, we wouldn't have thought entrepreneurship. And that's really key. I would strongly advise that anyone in entrepreneurship, that you don't go into it for the sake of being an entrepreneur. You do it for the right reasons. Because if you do things in life with a clear, positive goal, then automatically, when you're open to developing your skills and embracing the skills of others around you, you will be able to become what you need to become to do it and to retain that energy. And I think that's the key thing here. Whereas if you do something for the sake of doing it without thinking about the key goal, without thinking about the bigger picture, it's not going to be as fulfilling long term, and you're not going to necessarily make the best decisions.
That's great advice. Absolutely. I'd like to also think about the broader applications in the field, because I think, you've obviously got a deep expertise in machine learning and its applications to healthcare. Obviously, you've chosen to focus on one particular aspect of that with OXcan. But where do you see the field going in general? And do you think machine learning and artificial intelligence will become important in delivering healthcare?
Yeah. So in OXcan, so lung cancer is our initial focus, but we also have, actually right now, we've already analyzed samples from other types of cancer as well and other cancers. But our idea is to go beyond cancer as well. And the variety of plans we have beyond cancer to use a similar process of the biomarker discovery that we have. I think if we look at the field as a whole and also internationally, the answer is, for sure, machine learning, AI, AI is often a buzzword. People get excited about AI. What does it mean? But machine learning has been around for many, many decades. It's just that what we didn't have is the vast data and also the computational power to make use of it. So in 1950s, 60s, 70s, a lot of the seminal papers in the area of statistics machine learning came out in the 20th century, basically. But there have been advances in the techniques too. Combine the data with those. And what we're doing, what's really unique in terms of also all of our core technology, is it's a new use of how you integrate those analytical techniques with the actual data in a completely novel way. That's really the key thing. And I think that's just a microcosm of the whole healthcare space for machine learning and AI, which is tools exist, but how do you combine them? And how do you ask the right questions? Because at the end of the day, we live in a world where all of us as human beings, we're taking in data all the time. Whether it be visual, whether it be acoustic, we talk to people, we hear things in the media. There are things people sense intuitively. We, from a very young age onwards, from the moment that we were babies, our brains get used to being able to filter out certain key aspects and separating out from others. And that helps us to navigate day to day. Otherwise, we would be overwhelmed if we were just constantly focusing on everything. We wouldn't be able to do anything. And I think that just shows in microcosm, again, what the opportunities and challenges are in this space. Because when you have lots of data, and as it becomes more accessible with patients' consent and different types of studies in the world, and we have more computational access to more people, are we going to actually be able to identify the right questions to ask? Are we going to use the techniques in a way which is accurate, mathematically and scientifically, as a society? And is it going to lead to technologies that actually benefit people? So, people often speak about AI and machine learning and doctors, and would doctors be replaced or not? Well, the thing is that we have to understand how to make the best use of those tools. And I think ultimately it's not going to be a one or the other scenario where we say, yes, AI will be everywhere in medicine, or it won't be. It should be used in a way where it can make best use. So as a tool to improve what doctors are doing already, and not in a way which causes us as a society to be blind to what's going on. So I'll give an example of that. If we are trying to identify whether there are certain risk factors, environmental risk factors associated with disease, the type of data you actually use to train any form of machine learning or AI is going to heavily impact what you can identify. And if you miss certain variables, it could be certain environmental or lifestyle aspects. If you miss that out from the data, you might lead to conclusions which are at best incomplete and at worst misleading. And then you may not actually get to solve core problem. And so I would say it's very important that people don't, for lack of a better expression, I think here's a good one, is people don't deify the concept of artificial intelligence or AI. It's a tool. It's not an end in itself. And with that attitude, I'm sure we can do a lot of good things in society in general. A key thing also is it actually going to lead to patients having better well-being? So it's all well and good saying that there are new shiny tools that exist in the medical profession. And the answer is already we've seen positive transformative potential. So for example, in the context of both preventative disease, where we can see epidemiological factors, or you can see particular genetic risk factors, or in terms of certain targeted personalized treatment, where you can really look at data and ask yourself who is likely to do better, or which particular molecule as a drug is likely to be effective because of its actual structure, based on computational biobanks and libraries, and then matching that onto certain patterns in molecules that we have in our own bodies. I'm just keeping it general, but there's certain specific ones you can go into. That's a great example of what can go well. And then let's not forget that the whole point in medicine is we want to prevent problems if we can. We want to detect them early and do something about them early, if possible, if we haven't been able to prevent. And finally, if in the worst case scenario, a disease is quite chronic in nature, or we've missed it in the first phases, then we want to be able to do something to help patients there. And so it's important to make sure that we don't close ourselves off to the opportunities with AI and machine learning medicine, but at the same time, it shouldn't become the end in itself. We want to still help patients to have a better lifestyle in the first place, not just rely on what we can do well once there's a problem, but we do want to help people if there is a problem, so they can hopefully reverse and get back to where they can be in terms of health.
It's very interesting listening to you talking about machine learning as a tool, because I think you're absolutely right. It's one of an arsenal of tools that we have to make healthcare better. And sometimes I think people do get very excited about the next new thing, the next new technology, and they assume that it's going to solve everything. Whereas actually, in fact, of course, it just adds to the armory in a sense. It adds to the things that we can use to address disease. It feels to me that you talk first about prevention, then about diagnosis, and finally about treatment. It feels to me like that's not the way the healthcare service is structured at the moment. And so there are some challenges that are perhaps societal or cultural about having that focus, not necessarily about the technology. But I don't know if you feel that the technology could encourage that, whether you feel that this technology has applications in prevention and diagnosis that could therefore sort of draw the health system in that direction.
I think so. And first of all, it's also really important, I think, just to acknowledge how a lot of people are making lots of good effort. Clinicians, nurses are working so hard in so many different ways, and patients are working so hard. And of course, things aren't easy for people, depending on people's experiences when they're growing up, their childhood, their formative years, physically, psychologically, what they're exposed to, what they do and don't do. It's really not easy. And so it's all well and good saying, you want to prevent a problem or you want to do something in the early stage, but in practice, it's hard to do. That said, there are ways in which we can foster that. And I think that there are lots of initiatives, and there are initiatives across the world. There are initiatives in groups within the UK and other parts of the world to make it easier as well. And now, compared to a few decades ago, in many ways, there is much more awareness now in terms of lifestyle and prevention as well. And it's in terms of technological tools, it really depends, because we're now in an environment, culturally speaking, where we're very used to interacting with computers, mobile phones, other forms of gadgets and accessories. And so people do have more exposure to information by far. But then again, that comes with its own benefits and disadvantages. It's always a matter of, can you make the best use of it? And if there's more information, that's good if you're homing into the good information, the accurate one, and you have the right tools to use it properly. But if not, then it can also be quite confusing, and it can also lead to the wrong conclusions. So yeah, using machine learning and AI to help people perhaps be aware of various aspects of their day-to-day life or in clinical care along the journey of recovery, it could definitely be helpful to support people with that, to give that more supportive network. And I would say that should be explored, and that should be continued to be progressed. And at the same time, also the human factor, which is the interaction between people in society as a whole, community groups as well, to foster that type of collaboration, so that people can have a routine where they can be in a healthy way of living if possible. And if they're going through a difficult experience and they're in a treatment pathway, they have that support. They know that there are other people who are on that journey with them. And again, it's like what we were saying before, it's another tool, and it's a tool which can be used for good if we focus on it. But obviously, if not, then there are problems as well. So it's about how we use it.
So what's your vision for healthcare in the future? In 20 years' time, what are we going to be looking at, do you think?
Yeah, that's an interesting question. I mean, ideally, I'd love it if we were in a society in around the whole world whereby, as much as possible can be prevented in the first place of disease. And we have really good personalized tools based on technological insights where appropriate to help people where there is a disease. And of course, this is a really broad statement, but of course, we can see some examples of that now already starting to happen on a smaller scale in some areas for certain diseases. Where we actually will be in 20 years, I wouldn't be surprised if we're much further ahead or less than people may think, because there's so many factors, and it's not just about medicine. There's so many factors to determine, of course, access to technology, focus on technology. One thing which is really clear is that people are going to be much more aware as a whole in society in the current trajectory of things which seem to be beneficial or not beneficial in terms of health. And there will be much more of an expectation from patients, in all likelihood, to have a personalized approach to that treatment. And I think that clinicians and nurses and patients are embracing that on a cultural level and also on a practical level, to really think to yourself, you've got somebody as a human being, there are so many aspects affecting their life. How can we take into account what they're currently doing in their life, what their difficulties are, not just within the biological, but also holistically as a person, occupation, family life, other aspects, and how can we use that to have an informed, objective intervention or monitoring where appropriate medically, as well as also guides on a psychological level to do that. And I would say that depending on whether somebody is in an area of the world where there are more resources or less, perhaps the extent to which we do that will be different, or the focus will be a bit different, but the same principle overall would still be the likely trajectory.
And obviously OXcan is going to contribute to that, I imagine. I mean,
Hopefully
what are the next steps for OXcan? Where are you going?
Yeah, so we've got lots of clinical studies internationally, prospective studies looking at patients over time who are at risk of disease, where we're looking at their blood samples and we're measuring the biomarker candidates that we have for those patients so that we can distinguish between cancer patients and patients without cancer. For lung cancer as a starting point, but also others. So we have been doing studies for a number of years already. There are studies ongoing. There are new studies which we're starting in the UK and beyond. And what it is that we are really excited about here is the ability to bring very quickly the research and developments to patients clinically, so where they can be used. So we're hoping to have pilot implementation of products for patients in the next couple of years already, depending on where we are. So in some cases, for example, the research that we're doing, the whole biomarker discovery pipeline that we have ready to offer now for collaborators. And then we have different iterations of our products starting from next year and then beyond there for patients in different risk groups, which we'd be offering. I would love to see OXcan continue in this trajectory. We're in a really good position. Everything is going the way it should be going here. And now it's just a matter then of also awareness, which means for us to communicate in the right way with clinicians and patients so that they know the tools that we have available to help and where that can fit in. So that hopefully in the future, patients who are at risk can have OXcan's tests with high sensitivity and specificity to detect the lung cancer and other types of cancer very early on. So that person can then go into that pathway. But ideally, of course, if we can be in a situation at the same time where, for example, smoking cessation programs or other types of programs in society continue to work and people become better educated, then hopefully we can also, both OXcan and also society as a whole, become much more targeted. Because there are some people who it's very difficult to based on where they've perhaps lived when they were younger, it's very difficult to change certain things now. And we need to have technological tools to help them. But we don't want to repeat generation after generation the same types of hardships and mistakes which can lead to those diseases.
And you're obviously a the Hill Market Access Accelerator participant, and I know there's lots of things you'd like to do with us. Can you talk a little bit about what kind of support we have provided and could provide in future for companies such as yourselves?
Yeah, for sure. So one of the things that I really enjoyed about the Hill program is the interaction between clinicians, entrepreneurs in different contexts, investors, people who have previously gone through the process of innovation in medicine. The fact that you have that very clear connection to the NHS. I mean, throughout the Hill program, you really feel as if you are at the interface of the NHS by definition and what we're doing. And you also have other companies in that combination of the in-person presence as well as the virtual, the fact that you had interactions not only on certain days, but you also had opportunities for one-to-one conversations with experts in the field. And then beyond the confines of a certain day, you can also reach out and have that, you ask to be connected to someone and vice versa as well. And you can have that type of mentorial relationship going on. I think it's very important. It's one of the key strengths of the Hill is an interdisciplinary look at what the needs are of growing companies with technologies which can have an impact in the NHS and beyond, and making sure that there is proper contact and visibility of individuals in this space who have the expertise, who can connect to the companies. And there's a collegiate feel there in the Hill that people are there to help each other out, both the companies and also those who are teaching and providing advice in the program.
It's very much about a community, isn't it? And I think that sort of thread has come through very clearly in this conversation that, it is about multidisciplinarity. It is about bringing together different people with different perspectives. And it is very much about creating a community and an ecosystem, which then supports these sorts of innovations and hopefully makes life better for patients at the end of the day.
Absolutely.
Andreas, I know that you've been named as a 30 under 30, I think, by Forbes. You've obviously got a very successful company. You've got very interesting background, both in medicine and in mathematics. What's next for you, and where would you like to go next?
Yeah, so the Forbes 30 under 30, there was a few years ago now. It was myself and Peter who jointly recommended that. But again, I have to say thank you to the whole team at Oxford Cancer Analytics, because it is really a team effort. And without everyone's contributions from everything day to day, whether it be work in a lab, whether it would be analytics, whether it be, on commercial strategy, without everyone's contribution, we wouldn't be where we are now as a company. And I think myself and Peter's nomination for the Forbes is a reflection of that. But again, it's always a matter of what are we going to do with what we have? What do you do with knowledge when you have it? What do you do with skill sets or networks when you have them? And that's a key thing. It's not having, a certain nomination or whatever. It's what can you do with it? So the key thing for me personally, as it is also in the company, is to do good things with what I have. And that means continuing to learn from people around me, to really develop my own skill sets where I have strengths to continue to develop them, but in areas which are new to me, to learn from people who have been through that before. And within OXcan, to really drive our work forward so that our products can be used by patients. And as we continue to expand the number of patients, hopefully can benefit, will increase both in the UK, in the NHS, and beyond internationally, in North America, in Asia, beyond in the world as a whole. And for me personally, I want to make sure that what I do has a legacy of interdisciplinary application for societal goods. And the form that will take, I'm very open-minded, because again, 15 years ago, I wouldn't have known what I'm doing now, but it very much aligns with the way of thinking from then. And so maybe in 10, 15 years from now, I suppose it's a similar situation.
So any final pieces of advice for people starting out on an entrepreneurial journey or wanting to make a difference in healthcare?
Yeah. Focus always on what really matters. Ask yourself, is there a need? Is it an area where you yourself have some form of insight, or perhaps friends or others? Do things for the right reasons. Don't do it for the sake of doing it. And don't be scared to start the journey. It's like everything. It can be work. It can be sports or physical exercise, or it can be anything. It's often difficult for people to start something. But once they put in that initial energy and focus, and you overcome the initial perhaps barrier or a sense of procrastination of starting, then you realize that you can go much faster. You can be much stronger in what you do. So begin sooner rather than later. Humility, open-mindedness to learning from people who have more expertise, but at the same time, focus on the objective reality of what you need to do. And if you have that attitude, then whether it be the first entrepreneurship journey, or whether it be one later on, or whether it be something in life in general, which has nothing to do with entrepreneurship, that's the key thing. Remember that everything is interconnected, and people have so much that we can help each other with if we come to what we're doing with the right attitude. Yeah, try to do good things with the skills you have.
Some fantastic advice there. Thank you, Andreas. And thank you so much for joining us on the podcast. It's been a pleasure to have you.
Thank you.
You've been listening to the Hills Digital Innovation Podcast. Find out more about our work bringing digital technologies into the NHS at www.thehilloxford.org. You'll see details of our open access events, as well as applications to programmes such as our flagship Market Access Accelerator for startups looking to work with the NHS. Don't forget to also check out Series 1 and 2 of the podcast.